Hello, in this video we're going to talk about how to solve systems of equations in three variables where we end up with an infinite number of solutions. So usually the hardest part about this for most students is just figuring out how to write the answer when you come up with something that is infinite solutions. So let's go ahead and start this one. Notice over here that I did name each of these. So I have my equation 1, equation 2, and equation 3. So remember, when we're solving systems of equations in three variables, we're going to start off with two of the different equations, and we're trying to eliminate one of the variables. So when I look at this, it seems easiest to me to be able to eliminate the y's, because I see if I multiply this bottom equation, equation 3, by 4, then my y's would cancel out. And if I do the top equation by a -4, then again my y's would eliminate, and that's what I'm looking to do. So let's start off. I'm going to first write down, so I'm going to eliminate the y variable in this one. So I'm going to start off with equation 2 and equation 3, right? And so to equation 2, I'm just leaving that just like it is. Don't need to do anything to that. But with equation 3, I need to multiply that whole thing. All right, so I'm going to kind of show it this way. I'm going to multiply all of equation 3 by 4. All right, so if I multiply that whole thing by 4, then I end up with -16x plus 8y. Then I have 4 times -14 is going to give us a -56z, and then that 4 times -6, make sure you always remember to multiply by that last one too. Sometimes people forget to do that. That will be -24. All right, so now I am going to add these together, and when I do that, I see that my y's eliminate, which is what I was trying to have happen. All right, but let's add the other parts together now. So 20 minus 16x is going to give me a 4x. 60z minus 56z is going to give me a -4z. Sorry, a positive. We got a 60 minus the 56, so positive 4z equals -4. All right, so now I'm going to call this new equation that I just made when I eliminated those and added it together, I'm going to call this equation number 4. All right, so I've got 1, 2, 3, and now equation 4. So to find our next equation, equation 5, like I said, I'm going to take two of the other equations and eliminate the same variable. It's always really important that we eliminate the same variable. So that means I'm going to take this top equation this time, and I'm going to multiply it by a -4, because if I do that, then I can see -4 times -2 gives me a positive 8y, and then when I subtract off that 8y, my y's will eliminate again. So again, that was what I was trying to do. So equation 1, all right, I'm going to distribute that -4 through, so that gives me -36x plus 8y, and then -4 times -4 times 19 is going to give me a -76. So I've got a -76z, and that's going to equal -4, right? Multiplying that -4 by everybody. All right, I just want to double check my signs, make sure I have those all correct. All right, and then I'm going to add it to equation 2. So I've got 20x minus 8y plus 60z equals 20. And so now, when I add these together, again, I see that my y's eliminate, which is what I wanted to have happen. Right? I want to eliminate the same ones I did over here. And I'm left with negative 16x minus 16z equals a positive 16. And again, I made a new equation here just so it's easier to talk about which equation I mean. I'm going to label that one equation 5. Okay, so now if I try and eliminate another variable with equation 4 and equation 5, I'm going to go ahead and multiply equation 4 by 4. Because if I do that, 4 times 4x gives me 16x. And if I add it to that negative 16x, those will eliminate. So let me go ahead and do that. And I'll write it underneath here. So I've got 16x plus 16z equals negative 16. And so at this point, when I add these both together, something different happens than in some of the ones that we came up with. We see that both of these variables eliminate, and so we're just left with 0 on this side. There's no more variables to solve for, and I get this 0 equals 0. And that is a true statement, which is telling me that it is infinite solutions. But when you're trying to write that answer in and write it down, they're not going to just accept infinite solutions on this. So we got to make sure that we follow the directions up there where it says express them in terms of the parameter z. And so that means that when we first started off here, right, our z's completely eliminated out. So let me write the answers up here. So I know that z equals z. All right, and so that's going to be one of my answers that I have there. But I also need to figure out what x equals and what y equals. Well, to figure out what x is, I could go back to equation number 4 and just solve that for x. Because remember, equation 4 and equation 5 were really the same thing. It was just, one was a multiple of the other. And so I can take this equation. It didn't matter whether I went with 4 or 5. I'd still get the same thing in the end. But I'm going to take it and solve it for x. So I'm going to take that 4x plus 4z equals negative 4. And I want to solve it for x in terms of z. So I'm going to subtract my 4z over. And so that's going to give me 4x equals negative 4z minus 4. And then to get x by itself, I just need to divide everything by 4. So I get x equals negative z minus 1. So that's going to be my answer for x. So negative z minus 1. All right, so I just solved that equation 4 for x, and that's how I got that here. Now for equation y, there's a few ways that you could go about finding that, but one way that I think is a pretty easy way to go is go back up to one of the original equations where we have a y in it to solve for. So we don't have any y's down here. We eliminated them all. So let's go back up to equation 3. All right, so I'll write this here. So equation 3 says negative 4x plus 2y minus 14z equals negative 6. Now remember, I just found that the x is negative z minus 1. And so I can actually take that and replace it right? Substitute it in here in place of x, and then solve for y, because I need everything else in terms of z. That's why I need to substitute this in here. So that will give me negative 4 multiplied by the quantity of negative z minus 1 plus 2y minus 14z equals negative 6. So let's distribute that negative 4 through now. And so then I'll get 4z plus 4, right, just distributing that through, plus 2y minus 14z equals negative 6. Remember, I'm trying to solve this for y. All right, so let's get our like terms together that we can. So 4z minus 14z is going to give me a negative 10z. And then I still have my plus 2y plus 4 equals negative 6. All right, well, let's get y by itself now. So let's add the 10z and subtract the 4 over to the other side. So now that gives us 2y equals negative 10 plus 10z. And to solve for y, I can divide by 2 on everything there. So y equals negative 5 plus 5z. And that is what I come up with for my last solution there. So I'll put it up here and where I had it. So negative 5 plus 5z. And so now I have all of those solved, right? It was an infinite solutions, but I have those all solved in terms of z. And so those would be the solutions that I'd want to put in for my answers. Okay.